energy, and then the same thing happens at position number 5 as in number 1. Okay, so this is what we did on Friday. Okay, now we're going to do some calculations with that. It says there, a pendulum of mass 2 kilograms is raised 0.46 meters above its lowest point. It is released. Does it say it is thrown? No. So it's not thrown with the initial velocity, it's just dropped, it's just released. So the initial velocity, or the velocity there at the top, is 0 when they say it is released. That is your clue. That is just dropped. There's no velocity. How fast will it move at its lowest point? It's the lowest point. Okay. So, when you see a question that has a pendulum in it, or when you see a question that is free fall, meaning something is just falling, or when you see a roller coaster, anything like that, then you immediately go to this formula, the conservation of mechanical energy. Okay, Courtney, please give me the definition for the conservation of mechanical energy. Yeah? No, that's not conservation of mechanical energy. Okay, so the sum of the mechanical energy in an isolated system remains constant, meaning the mechanical energy at the beginning is equal to the mechanical energy at the end. Nothing was lost. Cloney, what is an isolated system? Yes, what is that? Page back. Okay, if you say closed, you won't get your marks in a test or an exam. There's no external forces, or there's no friction, no air resistance. Okay, so then I'm going to elaborate that. What is mechanical energy? It is the sum of the potential and the kinetic energy. Okay? And then we can elaborate it even further. mgh plus a half mv squared initially. Or let's do it like that. Do not forget your squares. Fine. Okay. Now, in a test or in an exam, you don't get a mark for each one of these things that you write. Okay? You do not. You get a mark once. So you do not need to write all 3 steps. Okay? What I'll advise you to do is write the first step and the last step there. Because let's be honest, you guys sometimes struggle to write down formulas or to remember them. Okay, and then if you don't write them, then thank you very much, then you substitute in the wrong things. Okay, we will hand it out when we are done. Is your timetable for the exams? It's hectic for you. It's long, it's not, yes, it's 4 weeks. But your last week is hectic. You end with last week and a half. Maths, business, geography, accounting, physics, accounting. Yes. All right. So let's start. So they say the first one that we must fill in there is the mass. Mass is in kilograms. It's 2 kilograms. 2 kilograms. G is the constant that is on your data sheet. That is 9.8. The height at the beginning is that vertical displacement is 0.46 plus 0. So why do I say plus 0? At the beginning, at the top, the velocity is 0. So that thing is 0, so that whole thing becomes 0. Okay? Is equal to, and then I say 0 plus blah, 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 blah. Why do I say 0 there? Sorry? No, there is a 0 for the initial velocity. My question is that 0 there. No. Dando? No, we ask what is the velocity at the end. So what is 0 there? Huh? Why is the potential energy 0?
Because it's not high.
Yes, it's at its lowest point.
Yes.
It can't go any lower. So because the height there is 0, the height is 0, then the whole potential energy becomes 0. Then we have a half, the mass is 2, and we want the velocity. Okay, where am I with my questions? Are you all checking Tandu? You don't trust him? What do you get in Tandu? Sorry, you have to speak up? Did you put the square root in? Not. So here you got 9.016, but we want the velocity, not the velocity squared. So you have to put a square root over it. Okay, 3,00, and then your unit. Meters per second, and the direction. East or right, or in the direction of motion. Okay, next one. A man drops a 2-kilogram ball from the top of the Pisa Tower. Do you know the Pisa Tower? Not Pizza. Yes, the Leaning Tower of Pisa. So they just build it skew. Next. All right. That is 54 meters above the ground. Calculate its speed halfway down the tower. Okay, now first let's see what information do we have here. What is the velocity of the ball there at the top, Rory? Why? No, that is not why. It can have a velocity there, but they say it is dropped. So, just like that. So he didn't throw it down. If he said he threw it down, then it needs to have an initial velocity, the starting velocity. But because it's dropped, it fell from his hand. So here, if I drop it, the velocity at the beginning was 0. Okay, so that word drop is your clue that the velocity at the top there is 0. That means that the kinetic energy at the top is 0. Right, then the height here at the bottom is 0. So that means the potential energy at the bottom should be 0 because it can't fall anymore. Now my question to you, Kutlano, is the velocity here at the bottom 0? Say again? The ball is dropped there at the bottom. Is the velocity, what is it? Is it 0? Not what is it? Is it 0? Okay. I'm doing the same scenario, sort of. I'm at the top of the tower. I have a massive brick in my hands. You are lying at the bottom of the tower. I drop this massive brick. By accident, on purpose, we don't know. And it falls. You say it doesn't have any velocity at the bottom. So it means it won't hurt you. You'll be fine. It does have a velocity. After it has hit the floor, ground, whatever, then it comes to stop. But that moment it hits the floor, it has a velocity. Okay? So whenever you get a question like this, and it's important for grade 12 as well, you must ask yourself, okay, what will the velocity at the bottom? Is it 0? I'm lying on the ground. Will I feel the impact? If the answer is yes, then yes, it does have a velocity. Okay. Right. So we don't know what the velocity is, but it's definitely not 0. Okay, so they say there, calculate its speed, the ball speed, halfway down the tower. So somewhere there, halfway. Areta Bile, what is the height halfway down the tower? Mooi, 27. And Relay, is the velocity 0 or at the halfway down? No, it's not. We don't know what the velocity is. That's the question. But it will definitely not be 0 because it's still falling. It's still going. Okay. So, how should you know that you should use this formula? Because they say something is dropped. Something falls. Something is in free fall. That is your clue. Okay. So you'll see I immediately go to this formula. Why do I do that? Because they ask about height and velocity and blah, 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 blah. What is this formula's name again? Wow. Starts with the C. It's a law of what? Mechanical energy. Hope, go for it. Go. The mechanical energy. We are listening. Page back. Yeah.
The total mechanical energy in an isolated system is
What is an isolated system, Carabello?
A system that has no external force.
More external forces. And Doctor, when I substituted this here, I filled in a 0. Why did I fill in a 0? Where is the velocity 0? At the top, the velocity is 0. Okay? Now I go to 2 times 9.8 times 27 because they say halfway down. So not all the way through, just halfway down. Yes? $54. Because that's at the top. Because I'm comparing at the top with halfway down. So this initial here is at the top. And this is halfway. Half times 2 times 3 squared. So please ask, like what you just did. If I fill in something and you don't know, where did I get it? Why did we say this? You know we're with you now, no?
Where did you get the
9.8 is G. It is a constant. It's part of the formula and you find it on your data sheet. Do you trust Bukamuso with your life? Then recalculate. Okay, good question. Okay, fill this in your calculator. Did you do that? What did you get? 1058.4. Okay, that's plus 0. We're going to ignore. What's this one? I hope you're not filling this in. Why should you not fill that in, Bugumuso? Because there's a plus in between, meaning it's two different terms. Can't add them together just yet. Just that. 529.2 plus, now in your head, what's a half times 2? Plus 3 squared. Okay. So you can't add this. None will you give back, you're not done. Alright. We want to get what is V. But they are currently attached to that thing. How are you going to get rid of that? And then when you take it to the other side, what are you going to do? Okay, do that. What do you get? 529.2. And then to get V, what are you going to do? 23 in your unit. Meters per second. Did I answer your question how to do it? You can do it now in a test. Yes. No. Okay. Then, yes. Down. Okay. B, they ask. Calculate its speed. Now, Shoni, speed is a scalar. Scalar does not need direction, but it's fine. We can give direction. Calculate the speed with which it reaches the ground. That speed there at the bottom. So now you have two choices. You can either compare the top with the bottom, or you can compare halfway with the bottom because you have all the information. I'm going to compare top and bottom because that's the least number of things that I need to fill in. So mechanical energy at the top is equal to the mechanical energy at the bottom. Okay, now I'm going to be lazy because I've already filled in all of that there at the top. I already know what is the value for the potential energy at the top. So I'm just going to fill that in because it's again plus 0. Then that is equal to, at the bottom, the potential energy is 0 because the height is 0, the potential energy is 0. Yes, at the bottom. Okay, plus a half times 2 times v squared. And Orna is on it. Yes? Yes? And your unit? Make this specific. Alright, so to practice this, your homework, no, not homework, classwork now is 1, 4, Khalid, please page with us, 1, 4 and 5. 1, 4 and 5. Okay, so please start with that now in class.